Okay, so today we'll finish up section 4.1, which is on solving right triangles. And the goal today is basically going to be, they're going to give us some information, and we have to find everything that we don't know about the triangle. So there's always 3 sides you need to find, and 3 angles. But since we're dealing with a right triangle, we're automatically going to know one of the angles is always how much? 90 degrees. So that's one thing you don't have to find. That's always going to be true. And in addition to that, you need to know a couple other things to solve the problem. Okay, so when you see the word solve, like in algebra, when it's an equation, it usually means to find the value of the variable. Well, when we see the word solve in a triangle, it means to find out how long is every side, how big is every angle. So when you're solving a right triangle, there's 2 cases you can have. So in addition to having a 90-degree angle, because that you have in every problem, so that doesn't really help you. You need either of the following of what I'm about to show you. You either need to know, in addition to the 90, another side and another angle. They have to tell you that. Or, does anybody know what else they could tell you besides another side and another angle? Anybody think, what else, what other combinations of things could they give you? Kristen? So like a side and what else? Yeah, besides a side and an angle. Not sure? You want to help her out? What do you think they could give you besides a side and an angle? Yeah. They could give you 2 sides. Okay? Either way, you can solve the problem. You couldn't solve it if they gave you 2 angles. Anybody know why it would be impossible to solve if they gave you 2 angles? Because if you gave you somebody 2 angles, you might as well give them 3, because if you know 2, you could find the 3rd one just subtracting from 180. So why would it be impossible to solve if you knew all the angles? Yeah?
You need a side so you
So sometimes we'll be able to use the Pythagorean theorem, but I agree with you need a side, but just not the because part. So you do need a side, but how come? Why can't you do it if you just have all angles? Okay?
There's no way to determine like how big that is because the angles, it could be a different scale of the angles is.
Exactly. Think of an equilateral triangle. If I said I have an equilateral triangle, it's a simple one. All the angles are 60, 60, 60. How big is each side? You don't know. The sides could be 2, 2, and 2, or 50, 50, and 50. You've got to have a side for scale. So that's why no matter what, you'll always be given a side. Then you could be given another side or another angle. So what we're going to do is we're going to make a sketch using whatever information they give us. And then we're going to organize that information into a table. Okay, so the triangle that we're always going to use when we make a sketch, we looked at it yesterday. What letters do we use when we label the sides? You remember those? Yeah?
ABC.
Yep. And is there anywhere that A, B, or C has to be?
C is usually the hypotenuse.
Yeah, C is usually the hypotenuse. And then A and B you can put as either leg. It doesn't matter. A, B. Now, we also have to name the angles. Does anybody remember the Greek letter we used for the name of the angle across from A? Yeah?
Theta.
We have used theta, and that is a Greek letter, but it's not the one that we normally use for the one across from A. theta looks like this. But we have used that angle in this section, just not for this diagram. Yep, alpha. We always put A across from alpha. And how about the angle that we put across from B? Yep, beta. Okay, some textbooks use lowercase and capital letters, like lowercase letters for the sides, capital letters for the angles. I like the way our book does it because they use Greek letters. What do you think could be confusing if you use lowercase letters for the sides and then capital letters for the angles? Yeah, some letters look the same whether they're lowercase or capital, unless you have a word or perspective to look at it. Okay, the letter C looks the same. Also, it clarifies if you ask me a question or I say something to you, like if you say, well, what is A? There's no question, I know you're talking about a side. If we used capital and lowercase letters, and you said, what's A? Then I'd have to say, well, do you mean capital A or lowercase a? Which one? So it eliminates that confusion. Okay, so Greek letters for angles, English letters for sides. All right, so here's our first problem. And this is the first case. In addition to knowing we have a 90, we have another side and another angle. So what I usually do is, I'm going to make a sketch in a second, but I just like to organize everything in a table. Okay, put your three sides in one column, put your three angles in another column, and what I've done is I filled in everything I know. Okay. B is 2. Alpha is 40. And I put the right angle as 90. That's going to be in every single problem we do. The boxes are things I need to find. Okay, they're things I don't know. Any questions on how I put that information in the table? All right, so now I'm going to make a picture because opposite, adjacent, and hypotenuse is going to come up quite a bit. So if you don't have a picture, some people might have a hard time visualizing what's across or what's next to what. So I'm going to put B here, which means beta goes across from it at the top. I'm going to put A here, which means alpha goes across from it. And I'm going to put C right there. You can draw your triangle any way you want, as long as you always keep the relationship that I just wrote down true. A is always across from alpha. B is always across from beta. Okay, but if you'd rather draw your triangle flipped around this way, that's fine. Just make sure you keep what I just said always true. Okay. What could I find first out of those three things that I'm missing? Without really anything that I've taught you. You could just use basic geometry. Wendy?
Beta.
Yeah, we could find beta. And how could you find beta?
You already have 90 to 40, so you need 80 to 50.
Yeah, so we already have used up 90. So that means the other two angles have to be 90, which means that angle has to be 50. Okay, that's one out of the three things we need to find. Questions on how we got beta? All right, so now to find A and C, it doesn't matter which one we do first. Okay, we can do either one. So which one do you want to guys find first, A or C? A. Let's find A. Okay, to find A, I'm going to go back and look at my diagram. I'm going to circle the two things that I was given. And I'm going to circle the thing that we just said we're going to find. So now I'm going to focus on the three things that are in blue. Now, technically, I have another angle I could have used. I could have used beta instead of alpha. But why do you think I chose to solve the problem with alpha and not beta? Could do it either way. Trevor?
Alpha's across from
My reason doesn't have to do with placement. It doesn't have to do with where things are. It has to do with something different. Anyone else think they could tell me why I used alpha and not beta? It doesn't have to do with the fact that 40 is smaller than 50. It doesn't have to do with that. But think about alpha and beta. What's a really big difference between this piece of information and that piece of information? Gabe?
They gave you that information?
Which one did they give me?
Alpha?
Alpha. So why would that be a better one to use?
You know it's right.
I know it's right. Okay? If I go back and use the information they gave me, I know it's right. So why would that be kind of dangerous if I use something I calculated?
You're wrong.
It could be wrong, right? And what happens if you use something that's wrong to find something else? Then the whole thing's going to be wrong. Okay? So that's the point. When we solve a triangle, we try not to use something we calculated, just in case we made a mistake, to find something else. Okay? We're always going to go back to the information that was given to us. Okay, so let's go back to the diagram looking at what I've circled. I want to figure out the names of the two sides that I'm working with. The side that I know, which is 2, and the side that I want to know, which is A. Okay. Relative to the 40 degrees, what is the name of side A? Your choices are opposite, adjacent, or hypotenuse. It's one of those three. This is opposite. And what about the side that's 2 units? What would be the name of that one? About by them.
Jason?
That's adjacent. So I'm working with the opposite and adjacent sides. Every problem today is going to use one of 3 trig functions: sine, cosine, or tangent. Which one you pick is going to be based on the 2 sides that you're working with. I'm working with opposite and adjacent. So out of the 3 trig functions I just said, only one of them has to do with opposite and adjacent. Which one? Sine, cosine, or tangent? Tangent. So to find A, we're going to write down tangent of our angle. Okay, what's the angle we're using in this problem? 40. Tangent of 40 equals opposite over adjacent. Mercedes, how long is the opposite side?
A.
And the adjacent side? 2. Okay, so now solve for A, and then we'll know how long that side is. Okay, so how about, Graham, how would we get A by itself here? Yeah, just multiply both sides by 2. By 2. There's your answer for A. Okay, we just need to type that in, and we'll round it off. Okay, what do I want to be careful about when I type it in on my calculator? I'm in the wrong, yeah, I got to be careful if I'm in degrees or radians. I'm in radians. This problem is not. Okay, so I need to switch over to degrees. Type in 2 tangent of 40. And I get 1.678. 1.678. Okay, so now we've got A, we've got B. Last thing I need to do is find C. Okay, what could I do to find C now, since I have 2 sides in a right triangle? Yep, I could do the Pythagorean theorem. But why, do you think, well, first question, do you think that's a good idea or not really a good idea?
I think it could be a good idea, but you found A, so that's something you found, so it's not completely reliable.
Right. So if you use Pythagorean theorem, you're relying on the fact that A is correct and you found it. So if you made a mistake finding A, you're going to get C wrong. So what we can do is we can find C the same way we found A. We can go back to the information that was given, so we're not relying on anything we calculated. And by doing that, if you make a mistake on one part, you won't necessarily make a mistake on the other parts. You could still get partial credit for the other two. So now we're going to find C. So I'll just circle everything in a different color. That was given. That was given. That's what I want to find. Okay, so this time, the name of the side that I know, it's still adjacent. But what's the name of the side that I want to know? I mean, it's C, but what's its position in the triangle? It's the hypotenuse. So focusing on the three things I circled in red, look at the two sides that I'm using. There's a side I know, it's adjacent. There's a side I want to know, it's hypotenuse. There's only one trig function that has those two in it. What trig function has those two sides in it? Josh? Cosine. So to find C, can somebody set up my equation to find C using cosine? Yeah, Marcus? Cosine. No, the 90 is not something I'm using. 40, yep. There you go. Cosine 40 equals
C.
So what is, can somebody help him out? Gabe, do you remember what cosine is?
It would be 2 over C.
Adjacent over hypotenuse. 2 divided by C. So the first thing we want to do to get C by itself is at least get it out from the bottom of this fraction and put it on the other side. So Emma, how would I get C on the other side? Okay, I multiply by C. And I have C times cosine 40 equals 2. And now I want to leave the C where it is, but I want to put the cosine 40 on the other side. So how about, Brianna, how would I move cosine 40 to the other side? Yeah. Divide by cosine 40. Divide by cosine 40. There's your answer for C. So notice what happened between this and the original problem. This is our final answer. C is 2 divided by cosine 40. Okay, the original equation I had was cosine 40 equals 2 divided by C. How did we get from this to that? If you just look at it visually, what did you do?
Divide both sides by C, divide both sides by cosine.
Well, that's the arithmetic we did. But look, okay, look at it this way. If you have triangle equals square divided by circle. Okay. We started with that. We ended with something that looks like this. Circle equals square divided by triangle. So how did I get from here to here?
Just switch the circle and the triangle.
Yeah. All we did was switch those two things. That's the general pattern. It doesn't matter what's here and what's here. You just switch them. Okay, so that's kind of a shortcut when you've got something that has the variable in the bottom, and it's just a fraction, and you have a number on the other side. Just switch them. And if you don't want to do it, you can go through all the steps that we just did, but that's all that's going to happen every time. They're just going to switch places. Okay, So now we just have to type that in and see what we got. Okay. Did anybody type in on their calculator 2 divided by cosine 40? What did you get? 2 point, can you give me 3 decimal places? Too? So for this stuff, we'll stick with 3 decimal places. Yeah.
2.611.
2.611. Thank you. And that's the problem. So now we solve the triangle. Now, what you could do is you could use Pythagorean theorem to check if you're right. You could try a squared plus b squared, get that number, and then take c and square it, get that number, and they should come out the same. If they do, then that's a good chance you did the problem right. If a squared plus b squared doesn't equal c squared, then either one of these numbers is wrong, or you did the Pythagorean theorem wrong when you checked your answer. Okay. So, any questions on that one? That's pretty much how the type of problem where they give you a side and an angle always goes. Just like that. You might not always use tangent and cosine. You might use sine and cosine. You might use sine and tangent. It depends on the side that you know and the side you have to find. Okay? Every problem's a little different. But same idea. All right, so take a second and try that one. See if you can find alpha, b, and c. If you have trouble or if you don't have a calculator, at least just try to set up the equation, okay, to find them. All right, so we'll start to take a look at it. Generally, if I'm given 2 angles, the first thing I do is just get that third angle right away because it's the easiest thing to find. So the third angle here, it's got to be complementary with beta. So how about Jocelyn, what'd you get for the third angle? 70. Okay. Now Dave, in terms of that angle, are we going to use it for anything else? No, we're going to forget about it. We have it. I wouldn't use it to find B and I wouldn't use it to find C. Okay? We were given an angle that we already know is right. Let's just use that instead. All right, now before I find B and C, about Gladdy, what should I do with that information in the table?
I drew a triangle.
Yeah, why don't we draw a picture? Because at first, sometimes it's hard to imagine what's across from what. If I put A there, I'll put B there, and there's C. Okay. What angle is going to be in the lower right, Riley?
Alpha.
Yeah, if I put A on the left, I got to put alpha across from it. Beta, you know what I'm going to do? I'm just going to label things in the picture that were given. So I'm just going to say it the way Riley said it. Alpha and beta was given. Okay. Any questions on my picture? All right, now Wendy, I want to find B and C. Does it matter which one I do first? No. Which one did you do first? B. So let's find B. I'm going to circle what she said we're going to look for. And I'm going to circle the 2 things I was given. All right. Brianna, what's the next thing I have to figure out about the B and the 6? Yeah, and how do you figure out if you should use sine, cosine, or tangent? Yeah, so we got to figure out the names of these 2 sides, okay? If they're opposite, adjacent, or hypotenuse. Graham, what's side B?
I got
I mean opposite, adjacent, or hypotenuse?
side B is
Opposite.
opposite.
Right, so we got opposite. And Marcos, what's 6? That's adjacent. Okay, so now we know the names of the two sides we're working with. There's one trig function that'll have those two sides in it. Trevor, what trig function would we use that has opposite and adjacent in it? Yep, I'm going to use tangent. So Emma, it's going to be the tangent of,
20.
yep, 20 equals, and Gabe, what's going to go on the other side? B over 6. Now we're going to get B by itself. So Mercedes, what do I do to get B by itself? Times it by 6. There's your answer for B. Did anybody type that in and get the decimal for it? Yeah, go ahead. 2.183. Okay, so now we've got B. So we could do Pythagorean theorem, but what would be not the best idea about doing that? Actually, two things. Gabe?
One, you can mess up on the Pythagorean theorem, or you could have messed up on B.
You'd messed up on B, but what if you didn't mess up on either one? What else could go wrong? Or what else could affect your answer? Look at B. Trevor?
Rounded.
It's rounded. So if I use something that's rounded, that's not exactly the correct answer, then that means C is also going to be rounded even a little worse, because I'm going to have to use something that's rounded, and then I'm going to round C when I get that answer too. So a couple reasons why you want to stay away from using B. All right, so let's find C. And this time we'll focus on the 6, the 20, and the C. C is the only side we hadn't labeled. It's the hypotenuse. And Michael, what trig function would involve the side that I want to know and the side that it was given? Cosine. Adjacent over hypotenuse. So we'll set up our equation. Cosine 20 equals adjacent over hypotenuse, 6 over C. And Kristen, what's the trick to get C by itself here?
Switch C and cosine.
Yeah, you don't have to go through all the arithmetic. We saw the pattern last time. You just switch those two. That's all that'll end up happening. And that's your answer for C. Okay. Does anybody have 6 divided by cosine 20 as a decimal? Let me get that, Michael.
6.385.
6.385. Okay, a couple quick things you can do to check your sides. Does anybody know what's the relationship between the sides in a triangle and the angles? Like the placement, where they are. Yeah?
The smallest angle has the smallest side, and the
Yeah.
biggest angle has the biggest side.
Exactly. The smallest angle should always be across from the smallest side, and the biggest angle should always be the biggest side. And there's another fact about just the sides. Does anybody know what has to always be true about the 3 sides in a triangle? Because I could give you 3 random numbers that don't make up a triangle. 2, 2, and 1,000. You're not going to make a triangle with sides 2, 2, and 1,000. They won't connect. So there's a rule that kind of helps you.
The hypotenuse is always bigger than the other 2 sides.
Yep, so that kind of goes with the thing I just said before. The biggest side is always across from the biggest angle. And the biggest angle is always the 90 in a right triangle. So we've got that. But something else just about the sides. Hmm?
2 sides added together always have to be bigger than the third side.
Yeah, that's called the triangle inequality. Any 2 sides added together have to be bigger than the third. So if you add 6 and 2, you get 8. That's bigger than C. 2 and 6, again, that's 8, which is bigger than A. And if you add C and A, that's 12.385, which is bigger than B. If that doesn't happen, something's wrong. Okay, so that's kind of a quick thing you can check to see if something's obviously wrong. All right? So keep those 2 things in mind. All right, so this one, a little different. Can someone tell me what is different about this problem? Mercedes?
You gave us 2 sides.
Yeah, I was given 2 sides. So this time I can't just add up and subtract from 180 to get an angle. But there is something I can do here that I'm okay with that I wasn't okay in the last two problems. What can I do now that I didn't want to do in the last two problems? Yeah?
Pythagorean theorem,
Yeah, why can I use the Pythagorean theorem now?
because A and B are both given.
Yeah, everything that I'm plugging into it is given, so I know it's correct. So we get c squared equals 9 plus 4. Jocelyn, 9 plus 4 is going to give me how much? 13. And my last step, Brianna, to get c by itself. It's already squared.
I mean, square root.
Square rooted, yeah. So there's the hypotenuse, square root of 13. The directions might say round that off to a decimal or leave it as square root 13. Let's round it off. 3.606. Okay, so now I'll make my diagram. I'm not going to label what I just found, but I will label the two things I was given. So I put A and B, and alpha and beta. So now we need to find alpha and we need to find beta. It doesn't matter which one we do first. So Gabe, you want to do alpha or beta? Alpha. Okay. So I'm going to do the same thing I always do. I'm going to circle the two things I was given. And I'm going to circle the one thing that I want to find. So to find alpha, all I'm going to do is focus on what's circled in green. What's the name of the side that's 3 units long?
Opposite.
That's opposite. And 2 units long? Adjacent. So that means when we set up our equation, what trig function is going to be in it? Tangent. Because we got to deal with opposite and adjacent. Okay, we don't want to use hypotenuse because we calculated hypotenuse. It could be wrong, and it's rounded. So, tangent of alpha equals, and what would go on the other side? 3 over 2. Now, what's a little different about that equation? Compared to the last two equations we had. Okay, we have that Greek letter. Where is the Greek letter? Yeah, it's in the tangent function. Okay? This is being plugged into tangent. So now we have to get alpha by itself. So the way you get rid of a function is with another function that does the opposite of it. Like if you had something like this. This is a problem that has the squaring function in it. How would you get rid of squaring? Square rooting. You've got to use another function. You can't say divide each side by 2 because it's not 2 times x. This is a function. So you have to cancel it with another function, square root. Right? So same thing here. We have tangent. You can't add, subtract, multiply, or divide because tangent's not a number. It's not a letter. It's a function. What function would cancel out the tangent function? Yes, you do the inverse tangent. And we're not multiplying by the inverse tangent because you can't multiply by a word. Just like here, you wouldn't say multiply both sides by square root. No, you just say take the square root of both sides. Take the inverse tangent of both sides. You say it exactly the same way. So take the inverse tangent of the left, take the inverse tangent of the right, and we saw this yesterday. Inverse tangent and regular tangent cancel each other out. And your answer is the inverse tangent of 3 over 2. Okay, now just type it in and see what it is. inverse tangent of 3 over 2. 56.310. So 50 rounds up, 56.310. Okay. Any questions on how I got alpha? Now, I know all the angles in a triangle are going to add up to how much? 180. So why don't I just take and subtract 56.31 from 90 to get beta? Yeah?
You could be wrong.
Exactly the same thing I had said all class. You could be wrong. So I'm going to find beta the exact same way I found alpha. But if I'm pretty confident about alpha, I'm thinking the answer should come out to 33.69. Okay, so just remember that. All I did was just subtract alpha from 90, and I think beta should be 33.69 if I did alpha correctly. Okay, so let's find beta and see if that's what it comes out to. Okay, so I'll circle the two things I was given. I'll just use a different color. And what I want to find. Now, these names no longer apply because you're not using the same reference point anymore. You've switched your angle. So now, what is the side that's 3 units long compared to beta?
Adjacent.
Now, that's adjacent. And what about the side that's 2 units long? That's opposite. It's the same two sides, they've just switched places. So what trig function does that mean I'm going to use? I'm going to end up using tangent again. Okay, so to find beta, it's going to be tangent of beta equals opposite over adjacent. But now the opposite and adjacent have switched places. So it's going to be 2 over 3, okay, 2/3. Yeah, I have to do the same thing I did in the last problem. I got to get rid of the tangent function with another function that cancels it out. And what function did we just do that cancels out tangent?
Inverse tangent.
Yep. So we're going to take the inverse tangent of what's on the left. We're not multiplying. Can't multiply by a word. So take the inverse tangent of what's on the left. Take the inverse tangent of what's on the right. And let's type in inverse tangent 2/3 and see what we get. Is that what we said earlier the answer should come out to?
Yeah.
Yeah, 33.69. So we're good. So since I got the same answer for beta doing it 2 different ways, I'm really positive that we did it correctly. If you got different answers doing it, it's those 2 ways, something's wrong. Okay, so that's the type where they give you 2 sides. The other one and the one before it was the type where they give you a side and an angle. Okay, so any questions on that one? All right, so last one we'll look at is a word problem. This is another one with solving 2 sides. It's just like the last one. I don't think we need to do another one of those. If we do, we'll review tomorrow, and we can do another one. Okay, so it says you're going to lead a 20-foot ladder against a house. The angle between the house and the ladder is 17 degrees. How high will the ladder reach? Well, it's a 20-foot ladder. How come the ladder won't just reach 20 feet high? Yeah, Josh?
It's on an angle.
It's on an angle. Okay, so if you put the ladder on an angle, it can't reach as high. Well, why do you have to put it at an angle? Why don't we just put it straight? Then we could reach higher. Might be a bad idea. How come? Yeah, you can't put the ladder straight, it's going to fall. So you got to put it at an angle. All right, so what do you think this problem really asks us, or what we need to do as our first step? Yeah, we got to draw a picture. So in our picture, we need a house, we need a ladder, and probably something for the house and the ladder to be placed on, which would be the ground. So there's the ground. Here's our house. Just go like this. Like that. And now we're going to lean the ladder up against the house. Okay, so here's our ladder leaning against the house. All right, what do we know? A couple things we know in this problem. What do they tell me? Gabe?
The angle between a ladder and a house is 17 degrees.
Okay, so where is that in this picture?
That's
Oops.
the one closest to the roof.
Yeah, this is the ladder on the angle, and the house is hopefully what looks like a house to you. So it's the angle that's at the top. Okay? It doesn't say the angle between the ladder and the ground. We could find that if we wanted it, but that's not what they're asking for. So that's 17 degrees. And what else do we know?
The hypotenuse,
Yeah, we know the hypotenuse of that triangle is how long?
20.
20 feet. It's the length of the ladder. So what I'm going to do is draw that triangle off to the side. 20, 17. We're going to assume the house is perpendicular to the ground, which isn't necessarily true, but we're going to hope it is. And what is it that I want to know in this triangle? To find how high the ladder will reach. Gabe?
You want to know one of the sides?
Which side?
The side that's the house.
Yeah, I want to know the height. Okay, the vertical side of that triangle. So let's just call it X, or A, or B, whatever you want to call it. So now we're going to do this just like a normal problem. Circle the two things you know, circle what you don't know, and figure out what trig function you need. Anyone think they can tell me the trig function that I'm going to use without me going through it step by step? Yeah?
The whole equation or
Just the trig function.
cosine?
Yeah, we're going to use cosine. So the cosine of 17 equals adjacent over hypotenuse. The adjacent is x, and the hypotenuse is the length of my ladder. Okay, so my last step, get x by itself. Riley, how do I get x by itself?
Multiply each side by 20.
Multiply by 20. Type that in on the calculator. And that's how high the ladder will reach. So it's 20 cosine 17. 19 point, let's say about 19.13 feet. So really, you don't lose that much height by placing the ladder at an angle. Did anybody have a guess what angle you could put the ladder at? I mean, it wouldn't be practical because it would fall. But what angle you could put the ladder at and you could only reach half as high. So a 20-foot ladder would only be able to reach 10 feet high. Josh? All right, so a lot of people guess 45 because they think, well, if you put it at a 45, it's like 90 is halfway between 0 and 45. Well, if you try typing in 20 cosine 45 instead, watch what happens. You don't get 10. You can actually, the ladder would still reach up 14 feet. So, yeah, it has to do with 30s and 60s. If you put it at a 60-degree angle, which again is not practical, then the ladder would only reach half as high. But it's not really intuitive, because 45 is always the first thing people think of. 45 is halfway between the ground and vertical. But it's actually a 60-degree angle you'd have to put at the ladder. So your ladder would basically be like that, which, again, wouldn't work. Good. Any questions on that? All right. So you've got about 15 minutes left. And I'll give you the rest of the time to work on the homework. There's some extra books on the counter. Okay, so it's on page 255. It's 31 to 39 odd, 43, 47, and 51 through 55 odd. Okay, tomorrow we'll do a review. Okay, get ready for the test. The review will cover everything in section 4.1, but not what we did in 3.1. Okay, test on Friday is on section 3.1 and 4.1.